Yes, Doctor, we can.
All right. Okay, so today what we're going to do is we're going to finish up the chapter 10 on one sample test of hypothesis. Okay, so minggu ni minggu terakhir kan? Is it not? Yeah, right. So hopefully after the term break, the semester break, we're going to look at two sample tests of hypothesis. So for this week, we're going to finish up this chapter. Okay, now last week, what we did was we tried to make a hypothesis or hypothesis testing on one sample test. Okay, one sample kan. Okay, and this is the example that we were looking at. Okay, on assembling a model A325 desk at a plant which have mean of 200 desks and standard deviation of 16. Jadi ini adalah example yang kita tengok lah last week. And we would like to investigate whether the production has increased or is different from 200. Jadi ada new method introduced in the plant and they would like to investigate whether the production is different from 200 and we choose at 0.01 significance level. Okay, and what you did last time was, okay, you make a hypothesis. Okay, so this is the most important part of a hypothesis testing. That is, the first part is you need to make the hypothesis. Jadi statement kita adalah, nampak tak H1 ni? Nampak kan? Okay, nampak. And if you look at the what you want to investigate, okay, nampak ni? Okay, ini adalah apa yang awak nak investigate. You want to investigate whether the mean number of desks produced is different from 200. Okay, nampak different from 200. Jadi cuba tengok H1. H1 mean is different from 200. Alright? Okay, jadi bear that in mind. And H0 is mu is 200. Mu is still 200. And H1 is mu is different from 200. Okay, jadi lepas daripada awak buat statement ni, okay, you make the hypothesis. Next is you select level of significance, which is at 0.01, alpha equal to 0.01. And then you select test statistic, the third step, okay, in which you choose Z. Okay, kita pilih Z sebab, okay, atas mula, sebab sample size besar, mana dia sample size, sorry. Okay, sample size is big, more than 30, and we also know that distribution follows normal distribution. Okay, and after you have decided what is your test statistic Z, okay, you formulate, and then okay, kita ada rejection region kan, okay, plus and minus, and then you make a decision. Okay, jadi make a decision whether Z value berada dekat rejection region or not. If it is in the rejection region, you reject H0. And then lastly, okay, this is also the most important part in which you would like to interpret the result. Okay, since we did not reject null hypothesis, so we have failed to show that population mean has changed from 200 per week. Okay, jadi apa maknanya ni? Okay, ini adalah, okay, we can tell our boss that the sample indicates that new production methods does not result in a chain of 200 desks per week. Okay, awak kena faham apa masalah sebenar, iaitu kita dah introduce new method to dekat kilang tu, dan berharap agar method yang baru ni boleh produce more than 200 deaths per week. However, daripada result awak, okay, awak dapati sebenarnya tak pun. Okay, so probably mungkin awak nak kekalkan dengan method lama, ataupun awak boleh terus, mungkin awak nak bagi masa lebih sikit ke untuk method baru. Okay, so it depends on your boss lah. However, the data here helps to decide. Okay, jadi apa yang awak buat kat sini adalah secara statistiknya awak guna data tu untuk derive to a better decision or conclusion. Okay, ada apa-apa soalan tak?
Doktor, yang ni untuk satu tail je kan?
Ya. Yeah.
Kalau 2 tail tu macam mana doktor? Dia bagi 4 ke?
Apa dia semula? Kalau 2 tail?
Kalau 2 tail tu dia bagi 4 hipotesis ke macam mana doktor?
Okay. Okay, that's a good question, Ashraf. Okay, jadi ini yang saya nak cerita lepas ni, iaitu macam mana kalau kita buat two tail. Okay, sorry, one tail. Yang ni adalah two tail kan? Two tail. Okay, two tail, kiri kanan. Okay, now we're going to you akan jumpa something called one tail test, and this is when, okay, bila masa, iaitu masa macam ni. Okay, tengok sekejap okay, saya kecilkanlah. Okay. Okay. This is a two-tailed test in which you would like to investigate whether mean is different from 200. So your H0 is mu is 200. Okay, ingat tak kita dapat X bar tu? Sekejap. Okay, kita ambil pen sekejap. Okay, kita dapat X bar adalah 203 kan? 203.5 ke something. Okay, data awak dapati. Okay, the mean number produced per week is 203.5. Okay, now nampak tak ni? Besar ke kecil daripada 200?
Besar.
Okay, it's bigger than 200. So, in this case, you can also test with one-tailed test in which you want to investigate whether mean is more than 200. Okay? Apa dia semula, Ashraf?
Just buat kesimpulan je lah yang dia lebih daripada 200 macam tu.
Okay, dia macam ni. Bila statement awak ni adalah less than 200 or more than 200, right? So nanti awak akan, saya tak tahu sama ada awak reject ke tidak, but most probably is going to be rejected. Probably, I don't know, sometimes dia punya critical value tu apa ni, a bit different. Of course it's going to be different, but sometimes kadang-kadang dekat sini reject, dekat sini tak reject. Okay, so it depends on the value that you have, right? Okay, so for one-tailed test, it's going to be different. Okay, because nampak tak ni? Ini adalah two-tailed. Okay, two-tailed 2.58 kan? Yang ni adalah 2.58 campur tolak. However, for one-tailed test, okay, jadi yang ni saya nak suruh awak tengok sekejap dekat normal table awak tu. Okay, if you have it with you. Okay, ada tak normal table? Kalau tak ada, sila tengok sekarang. Okay, in your normal table, okay, you have it like this, right? Okay, jadi ini adalah 99% or 0.01. Alpha is 0.01. And you got your critical value. as 2.58. Okay. Jadi awak boleh tengok dekat table awak. 2.58. However, for this one, okay, this one, awak kena ingat 99% tu dekat sini je 1%. Dekat ujung ni 1%. Or 0.01. So you are left with how many percent from here to here? 99% kan? Nampak tak dia tunjuk ni? Okay, 99% dekat situ. Okay, ini semua bahagian ni 99%, manakala bahagian ni adalah 1%. Okay, nampak? Okay,
Nampak
now, so, ya, okay. Kalau awak dah nampak tu, bermaksud, bila awak cari dekat normal distribution, awak tak akan dapat 2.58 sebab you will be looking at this area. What is this area? Can anyone calculate? Cuba calculate. Berapa tu? Saya nak area tu je.
uh, 0.49.
0.49. How do you know?
0.5
Okay,
tolak
because
0.0.
yeah, okay. Okay, very well done. Because awak tahu separuh ni adalah 0.5, jadi awak tolaklah dengan 0.01. Okay, so you got it as 0.49. Okay, jadi kalau 0.49, awak pergi kepada table awak dekat belakang sekali. Okay, dekat belakang sekali ni kan. Okay, saya tunjuk je lah. Okay, dekat belakang ni. Mana table awak? Okay, oh sorry. Oh yeah, that's the one. Okay, lain kali hafal page. Baru senang sikit. Okay, this is the one. Okay, ini adalah F distribution. Okay, biasa. Okay, this is the normal curve. Okay, nampak B3. And this is on page 789. Okay, 789. Okay, now if you look at the probability in here, okay, jadi refer dengan probability dalam ni 0.49. Wow.
2.3 lah tak? 2.33.
Okay, 0.49. Mana tak jumpa ni. Okay, 0.49. Okay, nampak This is the closest value. Okay, 0.49. 2.33. Okay, nampak 2.33. Okay. So that's why balik semula kepada page 358. Okay, that's why you have the critical value as 2.33. Alright? Okay. So ini adalah perbezaan antara two-tailed dengan one-tailed. So when you derive to your answers, Z nanti dia akan jadi berbeza lah. Z tu awak kira sama je kan. Z is 1.547. So Z 1.547 tu duduk dekat rejection ke non-rejection. Okay, so in this case, you're going to get similar answer because 1.547 also lies in the non-rejection region for one-tailed test. Okay? Jadi sebenarnya ini adalah apa yang awak buat untuk, saya rasa ada satu soalan kot yang saya bagi tu adalah one-tailed test. Do you realize that? Or you don't? Okay? Okay, P-value ni saya tak ajar lagi. Kita akan belajar bila dah dalam tutorial esok lah. Okay? Okay. Okay, now let's have a look at, yeah.
Nak tanya yang mana lebih efektif antara 2 tail ke 1 tail yang lebih efektif?
Awak rasa macam mana?
Saya rasa yang 2 tail.
Okay, dia macam ni Ashraf. Dia bukan efektif or tak efektif. It depends on what you want to test. If you want to, kalau awak cuma nak tahu sama berbeza ke tidak. Okay, itu je yang awak nak tahu. So, it's two-tailed. But if you want to know whether there is an increase ataupun a decrease, then one-tailed test is more appropriate. Okay? Jadi dia bukan kalau buat two tail tak bagus, buat one tail. It depends on your objective. Apa objektif awak? Kalau bos awak cakap, okay mungkin bos awak cakap saya nak tahu ada perbezaan ke tidak je. Saya tak kisahlah sama ada meningkat ke menurun. Saya nak tahu ada perubahan ke tidak je. Okay? Tapi for some untuk sesetengah perkara memang kita nak tengok meningkat ke tidak. Okay, kalau macam saya jadi bos dekat kilang meja tu, saya nak tahu meningkat ke tidak. Saya tak nak tahu ada perbezaan ke tidak sahaja. Okay? Boleh Ashraf? Menjawab tak?
Jawab tak juga.
Alright. So it depends on your objective. Okay? Apa yang awak nak tahu? Kalau awak nak tahu ada perbezaan sahaja, you do it two-tailed. But if you want to know whether there is an increase or a decrease, okay, one-tailed test is more appropriate. Okay, very good question. Okay, so yang ni awak buat kan? Okay, kita check Okay, so this is assume okay, this is about tires, okay? And the company knows that the tread wears out 60,000 miles with average, okay? Average 60,000 miles. And the standard deviation is known to be 5,000 miles. Okay, now this is what you have. Okay, and sampel size 48 and X bar adalah 59,500. Okey, jadi kalau awak sebagai manusia biasa, okey, tengok soalan ni besar-besar sikit. Okay, you know that company tu cakap 60,000 on average, tapi awak punya truck 59,500 dah pun tak boleh guna dah tayar tu, kena tukar tayar baru. So macam mana? Nak marah tak ni? Syahira, nak marah tak? Ke tak marah? Kata 60,000, tengok-tengok 59,500 dah tak boleh guna. Macam mana?
Marah-marah.
Marah lah kan? Okay, marah. Memang marah. Okay, however, you must understand that this average is based on 48 tires only. Jadi mungkin kita ada 1,000 tayar. Betul tak? Okay, so we want to know whether the experience is different from that claimed by manufacturer at 0.05 significance level. Jadi nampak apa perkataan different ni? Okay, different. Jadi maksud you going to do a two-tailed test. Okay. Jadi awak akan buat H0 mu sama dengan 5,000 dan H1 mu is different from or not equal to bukan 5,000. 60,000. Okay, 60,000. Okay, awak akan guna Z dan apa nilai Z yang awak dapat?
Negative 0.693.
0.693, are you sure? Ada orang dapat tu value lain tak? Okay, tak nak cakap tak apalah. Okay. Jadi bila awak dapat value Z tu, awak akan tengok sama ada value tu berada dalam rejection ataupun non-rejection region and hence you derive to your answer. Okay? Okay, McBurger. McBurger follows okay, at Warren Road. Okay, the quality assurance department sampled 50 customers and found waiting time was 2.75 minutes. Okay, cuba awak tengok ni 2.7 minit, 5 minit jadi biasanya 3 minit kan on average. So now it is less than 3 minutes. However, ini adalah based on 50 customers. So we want to know whether at 0.05 significance, can we conclude mean waiting time is less than 3 minutes? Jadi sebelum awak declare yang waiting time is less than 3 minutes, you need to test your statement first. Alright? Jadi in this case, this is a one-tailed test. Okay, jadi kalau one-tailed means that you're going to do H0, H1. Okay, teka dulu. Apa dia yang bawah, apa dia yang atas. Ataupun apa dia yang atas, apa dia yang bawah. Oh, sorry. Siapa nak teka ni? Okay, kita bagi RM10 lah kalau betul. Suka sangat duit lah. Cepat. RM10 Kita ada RM500 untuk diberikan. So RM10 is nothing. Tak ada orang nak jawab kan?
Kurang 3 minit.
Yang mana?
Hash note.
Hash nak kurang 3 minit. Okey, kejap ni kurang 3 minit. Yang ni 3 minit. Okey, ada siapa ni kurang atau sama dengan lah. Okey, ada siapa-siapa nak bantah?
Saya doktor.
Ya, Elmira. Elmira, macam mana? Apa awak nak bantah?
H0 mu lebih atau sama 3. H1 mu kurang bagus.
Okey, bagus Elmira. Nanti tambahlah akaun awak RM10. Sorry, yang ni. Okey, jadi sebenarnya, okay, this is the right one in which when you want to test whether waiting time is less than 3 minutes, macam saya cakap tadi, yang H1 tu less than 3 minutes and yang H0 adalah lebih besar atau sama dengan 3. Okay, Elmira, nanti kita PM tepi ya. Okay, so this is how you then derive to step 2, step 3. Okay, cari apa ni? Test yang sesuai mestilah Z sebab kita ada 50 customer. Okay, we have 50 customers, Z test. And then you look at one-tailed. Okay, one-tailed test. Okay, then sama juga dengan ini. Okay, sama juga. Okay, cuma sekarang ni awak nampak average more than 80. So, sekarang awak dah boleh guess kan apa dia H0, apa dia H1. Okay, can anyone? Okay, mu. Okay, more than letak sini lah. Okay, so this is. Okay. Jadi guna Z, alpha adalah 0.01, Z adalah X bar minus mu divided by sigma divided by square root of N, which, okay, masukkan nilai ni. X bar 84.85 tolak 80 bahagi sigma mana? RM9.95 bahagi punca kuasa 35. Okay, so you derive to your answer and you get your critical value. Kita belah sini lah kalau mau kan. Okay, tengok critical value berapa. Okay, refer to your normal distribution table. Okay, boleh? Okay, harapnya boleh. Cuma sekarang ni, hari ni, ya.
Nak tanya yang modern tu kenapa dia ambil sebelah kiri?
Sebab apa dia dah? Okey, awak tengok nanti kenapa dia ambil sebelah kiri. Sebab kalau ambil belah kanan tu macam pelik sangat lah. Okay, more than. Okay. Less than belah sini. Nanti jap. Okay. Oh, sorry. Tersilap. Thank you, Ashraf. Tersilap. Kalau more than belah kanan, kalau less than awak ambil belah kiri. Okay. Thank you, Ashraf. Pagi-pagi ni kan bila tak breakfast tu jadi lain macam lah. Okay, siapa belum breakfast? Angkat tangan.
Saya.
Okay. Ya, saya pun mengangkat tangan. You know, it's really bad if you don't have breakfast. Rasa macam di awang-awangan macam tu kan. Okay? Okay, anyway, the next part, okay, kita selesaikan yang ni sikit and then lepas tu kita berhenti, kita sambung dekat WhatsApp group. Okay, now this is on using t-test. Okay, t-test lagi mudah lah daripada normal distribution sebab nak cari critical value dia sangat mudah. Okay. Okay, now masa bila kita guna t-test, okay, kita dah tahu kan? Okay, when population standard deviation is unknown and usually this is when your sample size is less than 30. Okay, jadi biasanya bila sample size kita kurang daripada 30, kita guna t-distribution and masa ni pun biasanya population standard deviation is unknown. Right? Okay, so for example, we have here insurance company, okay, claims that mean cost to process a claim is $60. Okay, now dia ambil 26 claims dan tengok berapa cost. Okay, so sini ada 26 claim kan. Jadi 26 claim bermaksud less than 30. So in this case, you don't know what is population standard deviation. Okay, jadi dua perkara kat situ. Dalam sample size kecil dan population standard deviation is unknown. Therefore, we're going to use t-test. Okay, and it says here at 0.01 significance level, is it reasonable to conclude mean cost is now less than $60? Okay, jadi kalau kita nak tahu sama ada betul ke tidak, kita buat test. Okay, nampak ni more than less than $60, more than $60. Okay, now less than 60. Jadi H1 awak less than 60, more than 60 is your H0. Select significance level 0.01 alpha and then guna t-test because this is more appropriate for sample less than 30. Okay, x bar tolak mu bagi s divided by square root of n. Jadi awak pun carilah t. Jumpa tak t? Okay, saya tak nampak t dia dekat mana. Mana t? Okay, nanti awak kira berapa t dia. Okay, and then using the t-distribution table at the back of the book. Okay, dia mudah sebab awak boleh tengok level of significance either at one tail or two tail. So in this case, one tail, 1%. Jadi ingat tak? 25 tolak 1 ni yang, 26 tolak 1 adalah 25. Iaitu 2.485. Okay, so you got your T as negative 1.816 and your critical value is negative 2.485. So the computed T value lies in the non-rejection region. Therefore, do not reject H0. Okay, jadi apa maksud do not reject H0? Balik kepada kepala ni lah ni. If you don't reject H0, means that mu is more or equal to 60. Okay, jadi with the evidence you have, does not conclude that mean cost for claims is less than 60. Jadi nampak tak ni, awak bolehlah bagi tahu bos awak ataupun diri awak sendiri. Okay, the sample of claims could have been selected. Okay, bla bla bla. Okay, to put it in another way, jadi sebenarnya inilah yang lebih penting. The test result do not allow the claims department manager to conclude that the cost cutting measure have been effective. Okay, jadi rupanya dia buat sesuatu lah cost cutting measure ni supaya kurang daripada RM60 kan, tapi nampaknya tidak berjaya. Next. Alright. Okay, ada apa-apa soalan tak sebelum kita pergi ke WhatsApp group kita dan cuba beberapa soalan?
Tak tahu betul nak sebelum balik tak? Laju sangat lah.
Laju sangat? Laju sangat Laju sangat Ashraf?
Tak ada laju sangat.
Okay, kenapa tak stop tadi kan? Sebab saya pun macam dah expert sangat tu jadi laju. Okay, sekejap Syah, kenapa tak cakap tadi? Okay, kita mulakan semula. Okay, jadi sini kita ada data, 26 data. Boleh Ashraf?
Okay, boleh tak ada.
Okay, jadi kita ada 26 data dan sebenarnya company ni, okay kita baca soalan Insurance company reports mean cost to process a claim is $60. Okay, jadi awak sebagai bos dekat syarikat ni, awak rasa macam value ni agak melampau. Boleh tak kita buat sesuatu supaya cost tu menjadi kurang? Okay, jadi $60 ni is quite expensive. I mean, it's too much for our company. So what happened was they implemented a cost cutting measure in order for them to cut costs. Okay, jadi adalah sesuatu yang dia buat. Mungkin I don't know, adalah sesuatu yang dia buat dekat syarikat dia supaya cost tu dikurangkan. And then for 26 claims processed last month, okay, ada 26 claim kan? Okay, dan dia pun ambil lah nilai-nilai kos yang terlibat. Okay, nampak ni. Kos pertama. Okay, $45, $45, 48, 48 kurang ni kan? Kurang daripada 60 kan? Okay, kurang, but nampak tak? Ada value 76. Ada value tinggi lagi 78. 69. Okay, 63, 64. Jadi, it's a mix of everything. Okay, now we would like to investigate whether the new cutting cost method able to reduce the cost. Okay, claim cost to less than $60. Okay, boleh Ashraf?
Boleh tak ada.
Okay, boleh. Jadi apa yang berlaku kat sini adalah kita kena calculate lah berapa min. Okay, boleh tak awak calculate berapa min dekat sini? Masukkan dalam calculator tu. Jumpa tak? Ini lama sangat. Okey, RM59, 42 sen, betul? And with standard deviation 10.04. Okay, so these are the values that you should get for X bar and standard deviation. Alright, very well done Anis. Okay, now value tu awak keep dulu sebab awak kena buat step 1 H0 H1. Jadi H0 H1 ni kita dah bincang tadi, iaitu H1 mestilah apa yang awak nak test, less than 60. So H1 is mu less than 60. Okay, and significance level you already decided at 0.01. And when you want to select test statistic, Kenapa tak guna Z? Kenapa?
Sebab kita sekarang guna t-test.
Kenapa? Kenapa?
Yang 13 sebab tu unknown standard deviation.
Okay, population standard deviation tak tahu, ada satu lagi sebab. Syafiqah nak jawab kan?
Sample size
Apa dia,
kurang
Syafiq?
daripada 30.
Okay. Yeah, that's very well done, Syafiqah. Sample size kecil, kurang daripada 30. So you use this. And kita nak formulate decision rule tu adalah kita cari critical value. So you refer to this table at the back of your book. Okay. One-tailed test 1%. Jadi awak tengok dekat 25 sebab ini adalah degree of freedom. Degree of freedom adalah 26 tolak 1 ataupun N tolak 1. Jadi dapat 25. So 2.485 is your critical value. Boleh Ashrai? Okay, so this is how your diagram will look like. Okay, jadi biasanya saya suka buat diagram ni sebab supaya saya nampak negatif 2.485 dan computed T adalah negatif 1.816. Okay, jadi bila awak compute dapat T negatif 1.816, awak tahu dia duduk dekat non-rejection ke ataupun rejection region? Jawab. Oh ya Allah. Jawab. Rejection ke non-rejection?
Non-rejection sebab dia dalam.
Yes, non-rejection. Yeah, non-rejection. So if you know that it lies in the non-rejection region, so do not reject H naught. Jadi sebab tu penting kita tulis H naught. Okay, penting kita tulis H naught, do not reject. Apa maksud awak do not reject H naught? Maknanya jangan reject lah statement ni. Do not reject this statement. Okay, so you know that the cost is still 60 or more lah kan? Betul tak? Okay, so it's still average does not change. Okay, jadi tadi awak claim kata awak dah letak cost cutting measure so that cost of claim to be less than 60. However, nampaknya tak berjaya lah cost cutting measure awak. Sebab daripada test ni, awak tahu you cannot reject H naught. Okay? So, this is why, okay, kalau awak tengok ni interpret result, means that we have not disproved the null hypothesis. Okay. The test result do not allow claims department manager to conclude that cost cutting measures have been effective. Boleh faham tu Ashraf dan kawan-kawan?
InsyaAllah boleh.
Yang lain macam mana? Amma? Okay, so I assume that okay, boleh Okay, thank you. Okay, all of you are too shy. Okay, jadi kita pergi kepada WhatsApp group supaya kita boleh buat beberapa soalan. And tomorrow and the day after kita akan discuss on soalan yang awak dah buat sepanjang sepanjang awak belajar ni lah. Dan mungkin masa saya akan bagi hari Khamis ni kita ada kelas kejap lah ya, dalam setengah jam macam tu. Saya akan bagi project question untuk awak supaya awak boleh fikirkan bersama-sama dengan kawan-kawan awak sepanjang term break tu ataupun sem break, apakah tajuk yang sesuai untuk awak buat sampling dan sebagainya. Okay, so see you in the WhatsApp group. Alright. Okay, bye-bye. Assalamualaikum.